So in problem number 2, our theme again is still common basis. We need to be able to write both sides of the equation in terms of the same base, if at all possible. So in this particular problem here, it looks like we're going to have values in terms of 5. And 5 is a prime number, so it's going to be 5 to the x plus 3 over here on the left. But 1/5 needs to be rewritten in terms of 5. And if you think back to your exponent rules, what we can do is we can flip 1/5 and make it 5 to the negative first power. Taking the reciprocal of 1/5 and changing the sign on the exponent. And now that we've done that, we have a base of 5 on the left and we have a base of 5 on the right, which means that we can ignore the 5s, and then we can solve. We've got x plus 3 equals negative 1. Subtract 3 from both sides, and we get x equals negative 4. Well, once we determine what we think our solution is, the nice part is we know before we turn a test or a quiz in whether we have it right or not. If we type it back in by going 5 to the negative 4 plus 1, negative 4 plus 1, and that gives us, 5 to the negative 4 plus 3 gives us 0.2, and if we type in 1 divided by 5, we still get 0.2. So you have to type it in correctly, but if you do, luckily it worked out well for us, and hopefully it was skill and not luck. But once again, the key is common bases. We want to have common bases. So on problem number 3, looks like we have 5 again on the left side. 5 to the x squared plus 8 equals 125 to the 2x. 5 is a prime number. We can't rewrite that, so we're going to leave it as 5 to the x squared plus 8. But over here on the 125, we may need to make our factor tree, which is 5 times 25. And then 25 is 5 times 5. In other words, instead of writing 125, we can rewrite it as 5 cubed. There's 1, 2, 3 5s here. But remember, it's not just 125. It's 125 to the 2x. So what we have to do is we have to simplify this a little bit more. The left side of the equation, 5 to the x squared plus 8, isn't going to change. But over here, we're going to have to multiply those two exponents. We got an exponent with another exponent, 5 cubed, and then to the 2x. So we're going to multiply those two exponents together, and we end up with 5 to the 6x. But what we finally accomplished here is that we have a base of 5 on the left side of the equals, we have a base of 5 on the right side of the equals, so those are like bases. And we can ignore the 5s. They don't really cancel out. But for solving purposes, we don't need those values. So we're left with x squared plus 8 equals 6x. And let's move the 6x over to the other side. And when we do, we're left with x squared minus 6x plus 8 equals 0. Well, we see a squared in there, so hopefully when you see the squared, you think factoring. And x squared is x times x. Factors of 8 that combine to be 6 are 4 and 2. Negative 4 and negative 2. And And now at this point, I hope that you can tell me x equals 4 and x equals 2. I know I'm going to show some more work, but I hope that you don't have to do this then. X minus 4 equals 0. Add the 4 to both sides, so we get x equals 4. X minus 2 equals 0. Add 2 to both sides, and x equals 2. One thing to point out here is if you verify your solutions by plugging the values back into the original equation, we need to put 4 back into the original equation and check our answer. And then we need to put 2 back into the original equation and check the answer. So in other words, if we go back in here and we put this in, it's going to be 5 to the 4 squared plus 8. That gives us this scientific notation number. And then 125 to the 2 times 4 gives us the same scientific notation number. You have to put 4s in across the board, and then you can do the same thing with the 2s, which I'm not going to spend my time on right now. But do the 4s for the entire equation to check, then do the 2s for the entire equation to check. So when we look at problem number 4, it looks a little bit different from our previous 3 examples. But if we can remember that the key idea here today is that we want to have common bases. And the 3 bases that we have in this problem originally here are 9, 27, and 3. Well, we can break down 9 into 3 times 3. So that's helpful, because then this will become 3 squared to the 2x. Don't forget that 9 had an exponent. We need to keep that exponent in there. We're going to multiply this by 27, and 27 is 9 times 3, which is 3 times 3. So in other words, 27 is 3 times 3 times 3. So we're going to get 3. And I forgot to write my cube. 3 cubed. There's 3 of them. And then we can't forget that we have an x squared. And luckily, on the other side of the equation, we don't need to rewrite anything. But we do need to be familiar with our exponent rules to be able to solve this equation now. We're close to a point where we can actually solve, because we have everything written in terms of a common base, in this case on this problem of 3. And as we go back and look here, we can superpower that, which means that we're going to multiply those 2 exponents together. So we're going to get 3 to the 4x. 2 times 2 is 4 with an x. We also can superpower here, and we're going to get 3 to the 3x squared. Again, we're multiplying these 2 exponents. That's our rule. And on the other side then, we still have our 3 to the negative 1. Well, we have a multiplication process here on the left side of the equation. And when we multiply 2 terms that have the same base, what do we do to those exponents? We add. So this is going to be 3 to the 4x plus 3x squared. If we want to combine it, when we multiply, we add the exponents. And on the right side, we still have 3 to the negative 1. But what we have now is we have 3 to some exponent on the left side, 3 to some exponent on the right side. We have a common base, and we don't need that base to help us solve. We need the exponent to help us solve. So we're left with 4x plus 3x squared equals -1. And once again, we're going to have to factor on this problem. We're going to rewrite this as 3x squared plus 4x equals -1 to put it in descending order. And I should have moved the 1 over to the other side. Hopefully you did that already. So we have 3x squared plus 4x plus 1 equals 0. Now you've got a couple choices here on this one. I would recommend factoring on this problem. You can use the slide divide method or the split the middle method. But I just would like to show you here that in this problem, 3 is a prime number. In terms of factoring, 3x squared is 3x times x. We can't do anything else with that. And 1, although it's not considered prime or composite, in terms of the factors of 1, are only 1 and 1. So I'm not sliding and dividing right now. I'm not splitting the middle right now. But I was able to factor that problem because of the fact that our leading coefficient was a prime number, and this last number only had factors of 1. If you FOIL it, 3x squared plus 1x, 3x squared plus 3x plus 1x plus 1. So it does work out. And now what we want to do is we want to solve for x. And again, some of you can go directly to the answers and tell me that x equals -1/3 and x equals -1, and I'm fine with that. If you need to show a little bit more work, here it is. So we subtract 1 from both sides, and we get 3x equals -1. Divide both sides by 3. So x equals -1/3. Over here, subtract 1 from both sides, and we get x equals -1. Even though I'm not going to spend the time, don't forget that you can take those values and put them back into the equation. So you would have to put -1/3 in all the way through for your variables to check it. And then you'd have to put -1 in back into the equation for all the variables and check it. And they will, if you do take the time to do that, work out for you. So as we flip the page, same kind of equations. The process isn't going to change, even though we have an e in this problem. And just want to remind you that e is an irrational number. If you go to the division bar on here, second, and the division symbol, we get 2.718281828. It has a value, but what we want to do on this problem is we want to solve for x. So we need to find common bases. And the next part is that all of the terms in this equation are written with an e somewhere in there. In fact, over here on the left side, we've got e to the -x squared, and we can't do anything to that part of the problem. We've got e to the x and then squared. Remember, when we superpower it, we multiply those exponents. So this is e to the 2x. And then we've got 1 over e cubed. Well, we can flip and change the sign on the exponent. This would become e to the -3. Be careful on the second one here. E to the x squared. When you superpower it, you multiply it. But now that we have that, we have like bases. we need to condense it down. So e to the negative x squared, we can't condense that at all. But over here, just like on problem number 4, e to the 2x times e to the negative 3, when we multiply these two terms, we add the exponents. So when we simplify this, and I'll get rid of that double sign here in a second, but I just want to reinforce that when we multiply, we add the exponents. Now what we have an e on the left, we have an e on the right, we have common bases. We don't need to use e to solve. Our variable is here in the exponent. Negative x squared equals 2x plus a negative 3 is the same thing as subtracting 3. And once again, what we're going to have to do is we're going to have to eventually factor. I can recommend moving the negative x squared to the right side of the equation because it's a lot easier to factor when your x squared term is positive. So we get 0 equals x squared plus 2x minus 3. And now we can factor. X and x. Factors of 3 are 3 and 1. And it's plus 3 and minus 1. And once again, I hope that you can say x equals negative 3 and x equals positive 1. If you can't do that, then what we need to do is we need to take x plus 3 and set it equal to 0. X plus 1 and set it equal to 0. So when we subtract 3 from both sides, we get x equals negative 3. When we subtract 1 from both sides, we get x equals negative 1. And we could go back in here and we could check this. Again, not going to spend my time on that. Darn it. Thank you.
I'm not so confused for a second.
So apparently I made a mistake here. But luckily, it was caught by a student, so let's fix that. I don't know why I wrote, yes I do, but x minus 1 equals 0. We can add 1 to both sides. I said the right answer originally when I didn't show any work, and then I did it wrong when and hopefully we would have caught our mistake when we checked in our calculator. Thomas?
Can you skip the part where you just make the bases? Why don't you just cut out the bases?
I'm gonna just say be careful.
It's the same answer.
So as we look at this last one here, or close to the last one, once again, we want to write these problems with common bases. So with common bases, we have 2 to the x that we can't do anything with. But we can rewrite 32, and luckily it's part of 2 problems, or 2 parts of the problem with the 32. So 32 is 8 times 4, which is 2 times 2, and 8 is 4 times 2, which is 2 times 2. In other words, we have 2 times 2 times 2 times 2 times 2. So this is 1 divided by 2 to the 5th. And over here, 32 is 2 to the 5th. If we go back to the left side of the equation, that 2 to the 5th in the denominator, we can flip and change the sign on the exponent. So it's 2 to the x times 2 to the negative 5th equals 2 to the 5th. And we've seen it a couple times today. When we multiply with like bases, we add the exponents. So this is 2 to the x plus negative 5. And over here on the right side, we have positive 5, 2 to the 5th. We have like bases. Same value here as we have here. We're not canceling out the 2's, we're ignoring them to solve. So we have x minus 5 equals 5. And we can add 5 to both sides to get 10. Problem number 7. One last time. The key is like bases. We need to have like bases when we're solving these types of problems. And what's going to happen is we need to rewrite these values, 81 in terms of 3. We need to rewrite 243 in terms of 3. We know it's 3 because of the fact that 3 is a prime number in this problem. So we've done 81 already today. It's 9 times 9, and then 3 and 3 and 3 and 3. And then when we look at 243, well, 243 is 81 times 3. And so we just did 81, 9 times 9, and 3, 3, 3, and 3. So 243 is 3 to the 5th. And again, 81 is 3 to the 4th. So if we put those values back into our equation over here, what we've got is we've got 3 to the 4th for 81, and that's raised to the 3n plus 2. And 243, we just said, is 3 to the 5th, but it has an exponent of negative n. And then luckily over here on the right side of the equation, we have 3 to the 4th. So we've got a couple of more issues here that we need to deal with. But what we have is we have 3 to the 4th, then raised to another exponent. So we need to multiply those values together. And that happens in the numerator of our fraction, but it also happens in the denominator of our fraction too. So if we simplify this a little bit, we're using the distributive property, and we're going to get 3 to the 4 times 3n, which is 12n, and then 4 times 2 is 8. We distributed that 4 over the 3n plus 2. In our denominator, not quite so complicated, we simply need to multiply the 5 and the negative n together, and we get negative 5n. And then on the right side, we still have the 3 to the 4th. Well, we need to think back to our exponent rules, and when we divide, what our exponent rules say is that we subtract. So we can combine on the left side of the equation, and this would become the 12n plus the 8, and then it's going to be plus 5n. We flipped that value, and we changed the sign on the exponent. There's the plus 5n, and then that equals 3 to the 4th. So now, what we have is we have a 3 on the left and a 3 on the right, which are common bases. So we can ignore the 3's and use the rest of it to solve. 12n plus 8 plus 5n equals 4. 12n plus 5n, when we combine like terms, gives us 17n plus 8 equals 4. Subtract 8 from both sides, and we get 17n equals negative 4. And finally, 17 times n, our inverse operation is to divide, and we end up with n equals negative 4/17, which we could type back into our calculator and check our work. We could verify that it does truly work out